Okay, hello everyone. Welcome to this morning's session. It's great to see you all here early in the day after such a great evening last night. It's a pleasure to welcome you to the session on Microsoft Academic. Before we get going, I just want to say a word or two about the remainder of the schedule in the day. We've got several breakout sessions or parallel talks on different aspects of AI. So once this is over, we'll have one focus on machine learning and algorithms in AI, another one that's focusing on the actual hardware implementations or intelligent devices, and then one on the extremely timely and interesting area of quantum computing. So all that will be coming when we're done here this morning. It's a pleasure to introduce our speaker, Alex Wade. Alex is a director of scholarly communications at Microsoft Research. He's had a very long history at Microsoft with a particular focus on search. He's implemented the search algorithms in Windows as well as in Microsoft's intranet search. Now he's focusing mostly on cognitive computing and Microsoft Academic, and the academic work will be the focus of today's talk. So Alex.
Thank you, everybody, for getting up this morning after last night. I was considering missing this session this morning, but it's probably good that I came here. And also, I think many of you came by the booth yesterday during the demo showcase. So I'm going to go into a little bit more depth this morning about what we're doing with Microsoft Academic, and I'll paint a little bit fuller picture of the relationship between Microsoft Academic and some of the Microsoft Cognitive Services that we're also developing in tandem here. So I'll talk a little bit about the relationship between these two things. And because we only have a half day of the summit left today, we've timed it so that by the end of lunch, all of the clouds should have cleared out and everybody can head out to the beach today. So that's part of the planning for the session here. On Wednesday, when we kicked off, Rico talked about Microsoft's interconnected ambitions here, about reinventing productivity, about building the intelligent cloud, and about creating more personalized computing. And really our new mission of enabling everyone and every organization on the planet to do and to achieve more. And what we're doing within our group in Microsoft Research is taking a very small slice of that pie. Everyone on the planet is a lot of people. So we've modified this a little bit for our academic services to talk really about every academic and every academic institution, focusing in right on those. And specifically today, I want to talk about a couple of things that we're doing in this space. Around reinventing productivity, I'm going to talk a little bit about Microsoft Academic, which is really the sort of first volley in how we see taking some of the efforts that we're doing around machine learning and data mining and knowledge acquisition from content on the web, in this case around scholarly publications and scholars, and bringing that together into something that's much more than just a search engine, but something that we feel will actually help in the productivity of you guys from an academic perspective. This site itself is actually built on a number of layers that we are also releasing simultaneously under the Microsoft Cognitive Services banner. And so I'll talk about the relationship between these and how they actually help us build up these services, and then how you can use them as well, in addition to the web portal. And moving forward, what we'll be working on now and coming over the next couple of years is looking at how we create this more personalized computing experience with this data. So Microsoft and other companies are coming out now with personal digital assistants, things that you can talk to, interact with, act on your behalf, notify you about things, alert you that you may want to leave for the airport earlier if the traffic is bad, so it knows about your flight, it knows about the environment. And imagine what you could do if you applied that same thought approach to all of the processes that you have as researchers and as academics. What would happen if we could sort of focus in there and have a personal assistant that's really taking care of the things that you need in your academic life? So Microsoft Academic, as I said, is this new web experience. Well, we'll talk about that. It is the sort of logical progression of a project that we were running, originally started out of our Beijing lab, Microsoft Research Asia, almost a decade ago. And a service came out of that, originally called Libra, and then was called Microsoft Academic Search. And as a research project, that actually led to a number of other technologies, such as how the Bing team today is building up their knowledge graph. But the research project itself ended a few years ago, and we've taken those same concepts, we've taken the ideas there, and we've rebuilt this entire approach now in partnership with the Bing team. So they're taking care of all of the web crawling aspects of this, and we're doing the interesting work that is really domain-specific around the academic content. And simultaneous with that, a number of these services that we use ourselves to generate this graph are also being made available. So I want to touch a little bit on some of the elements of the service that I think are what we're targeting as ways that we can differentiate what we're doing here from some of the other services that exist. And the first one is really, if you think about most academic search engines today, they're still very much based on a traditional information retrieval aspect. They take every single document or every academic paper or every web page, and they really treat them as a bag of words. You take the words, you index the words, you may be doing some sophisticated morphology on the words, but ultimately you're treating the document as a bag of words, and you're treating the keywords, or sorry, you're treating the query terms as a bag of words that you're matching up. And you're coming back with a set of candidate documents and ranking those and putting them in front of the user. And question and answering in this world, if you're talking to a digital assistant, doesn't really work because all you're trying to do is match keywords to the documents. So we end up having to build sort of independent parallel question and answering systems around it. The approach that we're taking here is fundamentally, as Rico stated on Wednesday, is teaching our bots not just to take a document and find all the words in the document, but to read the document and to understand the document and map the human language that's in the document to the concepts, and building up a knowledge graph around these concepts, the people and places and things that are being talked about in the content, and build up that knowledge graph, and then simultaneously or in parallel, when a user comes to the system, whether or not they're talking into their device or typing into a search box, treating this as an opportunity for our processes to understand the intent of the user. What is it that they're trying to do here? What are they trying to achieve? I'm not just looking at the words in the search box, but that's a clue as to what the user is looking for. And one of the systems that we've developed, and there's examples of this running in Bing today and in Cortana, is taking the added step of not just having this be transactional, not saying you type something into a search box and we'll give you back a bunch of candidate documents and then you have to figure out which ones are relevant for you, but actually using constructs of human dialogue to ask clarifying questions, to provide digressive suggestions from the search engine. And we can do a lot of these things in parallel in the Bing search engine today. And we're bringing that into the academic space. So the second aspect of this is really the reach. As I mentioned, we've rebuilt this now on top of the Bing crawlers. So this actually enables us very quickly and very efficiently to find new content on the web. We're growing this knowledge graph, what we call the Microsoft Academic Graph. Let me go back one. This Microsoft Academic Graph on a weekly basis. I think last week we added about another 300,000 documents into the graph. And rather than just treating this as a set of publications, we have well over 100 million publications at the moment, but instead of just treating this as a set of publications, what our bots are fundamentally doing is reading each one of those papers and pulling out the concepts and saying, this is not just a string that represents an author, but this is an author entity, and that author comes from an institution. And this publication was in this particular journal or at this particular conference. And again, mapping these things into these concepts. So this is a growing knowledge base, a growing knowledge graph of academic content that is not only powering these experiences, but we're making available to you guys as researchers if you want to take the whole graph and pull that down and do your own research on it. We also realize, and the reason that we're making this graph available to people is that this is not just an exercise for us as Microsoft Research to do further analysis on how, for example, we do ranking over entities in knowledge graphs, or how we do data mining and entity extraction and entity linking, but we want to do this in partnership with the community. We want you guys to help out in this same space. And over the past year specifically, we've done a number of challenges that have sort of shared some of the challenges that we have that are represented as ways that we can invite everybody in and run it as a competition and see who can do the best in this particular space. So one example of that was the Wisdom Cup Challenge that we ran from about August of last year until through December, effectively. And the challenge itself was, given a set of papers, and we gave our participants access to 100 million plus papers in this graph. Given a set of papers, give us a static ranking of those papers. Which papers are more important? And you can look at things like the citation counts in the papers, but that graph also included papers that had never been cited before, brand new papers, tens of thousands, a million papers that came out in 2015 that were not old enough to receive any citation. So you have to be able to rank those as well. And during phase one of the competition, we used traditional information retrieval evaluation techniques. We took a set of expert evaluations, and each submission from the participant teams was then graded against that. At the end of phase one, we took the top 8 teams who are in the picture here, including one team here from Brazil. We had 4 teams from China and Taiwan. We had 2 teams from Europe, 1 from North America, and 1 team from here in Brazil in the final 8. And we took all of their rank approaches, and we actually flighted them in our Bing academic service over the course of about 6 weeks. And we did an online evaluation to see how well their rankings actually stood up to real-world interactions, and to see how end users interacted with those search results. So it was a very interesting sort of transition from a traditional information retrieval evaluation technique to an online evaluation technique. And this is important for us as Microsoft, because this is the way that we evaluate any new feature that rolls into our online search engines, into Bing and other services, is that we will flight these, take a small percentage of the traffic, do A/B testing on what we have today versus new feature, and we measure whether or not that has any noticeable effect on user satisfaction, on click-through, on success rates, et cetera. And so that's what we did with these 8 teams in terms of opening up Bing for doing these online evaluations. If I can go back here, we've actually taken that concept, and that will be run this year as part of the Trek conference. We're doing an open search track in Trek to actually scale this new approach up, and hopefully this will be something that we repeat year over year. For the Wisdom Cup, those top 8 teams that I mentioned, if anybody's interested in reading about their approaches, these papers are up on docs.com. Little plug for another service from Microsoft Office right now. They've got this service called docs.com that allows you to publish your Word documents and your PowerPoint presentations and PDFs onto the web. So go and do a search for Wisdom Cup Challenge, and you'll see the publications here. The Wisdom Cup Challenge ended in February. The conference was in San Francisco. Right now we're doing a second challenge this year. The first one we did with actually no cash prize. It was just for fame and glory of coming up with the best ranking algorithm. But for the KDD Cup Challenge that's going on right now, we actually put a $10,000 cash prize on first place. I think there's a second and third place cash awards that go along with this as well. And whereas the Wisdom Cup Challenge was about ranking papers, the KDD Cup Challenge is about ranking institutions. So given a topic, machine learning, information retrieval, neural networks, give us a ranked list of the top institutions in that area. And that challenge is going on right now. We're running it in multiple phases. I think the phase number 2 just ended. The leaderboard is up right now. We have over 500 teams participating. It's not too late to participate, so there's one more submission deadline that's coming up next week. So go back and tell your students to participate. And then we'll be taking, again, the top teams and holding a workshop around this at the KDD conference in August. The other aspect of what we're doing right now with Microsoft Academic is trying to be as open as we can, not only with the data and with the APIs, but also the algorithms and approaches that we're taking in constructing this graph. And so I'll go into more detail about this stack over here, but the shortcut version of it is that the graph itself, as I mentioned before, is available for you to download and do your own research on. We've released this roughly quarterly over the past year. So the last release of this was back in February. And if there's need, we can do another release. But we've also put an API over this constantly refreshed set of data. So you can query into this and get the as fresh data as we're putting onto the website itself. So the way that the cognitive services and the website relate to each other is basically this. We have this Microsoft Academic Graph that I'm talking about here as sort of our data. The way that we build that is by crawling content that's on the web. This content could be on publisher websites, it could be in institutional repositories, it could be on your link from your own faculty web pages. But we basically piggyback on top of the Bing crawlers, look for the academic content. We have classifiers that will recognize the content, and we run that content through a number of processes, such as an entity linking service. That pulls the things out of the documents. It says this is the author, this is the affiliation. It understands the context of the document itself and will link the concepts into these topical hierarchical terms. And that helps us produce this graph. From an abstract perspective, we have this graph. Yesterday at one of the parallel sessions, I talked about this knowledge exploration service. So I'm not going to go into any detail about this here, but the knowledge exploration service is something that you can use with your own data to generate your own web service effectively over the graph, any arbitrary data. And what we do here is we take our graph and we run it through the knowledge exploration service, and what that produces for us is this academic knowledge API. So this is a queryable REST endpoint that provides access to all of the data that's in this Microsoft Academic Graph. And these items here in teal are 3 of the examples of the Microsoft Cognitive Services. So you can sort of interact with this at any level. You can run your own data through the Entity Linking Service, you can run your own data through the Knowledge Exploration Service, or you can play with our data that's been run through that pipeline. And then we put the website on top of it. So everything that we're doing on top of the website is exposed via these APIs. You can build your own user experiences on top of the same data that we're using. Okay, so let me go into a little bit deeper dive then on Microsoft Academic. We want this to be much more than just a search engine. This isn't, let me say this differently, all of the use cases that we see when we talk to students and researchers and faculty is, yes, I want to be able to go in and search for a paper, but I also need to be able to stay up to date in my field. And that's not always best served by being presented just with a search box and trying to type in keywords and get information back. So a few of the things that we are starting to expose now, and this will be growing over time, are ways that we can bring fresh information to you, expose the information in the graph in sort of a zero query format, and then sort of do some playful things. We have some leaderboards in there. We expose things that you might want to put onto your calendar, etc. And so let me walk through a little bit of the site experience and show you what that looks like. So when I talk about a zero query experience, when you come to the site, without having to put your cursor in the search box or take any action, you're presented with information. And you can see over here on the left side, we have the domains of coverage. In the middle, we have a feed of information here. This is focused right now on computer science. And so what we're showing here is a combination of research-related news stories, as well as recent papers. So I'm a former academic librarian, and many years ago, well before my days at Microsoft, people actually used to come into the library as a way of staying up to date on the research, and we'd have the sort of most recent editions of all of the journals, and somebody would come in and browse through the table of contents and say, yeah, that's the paper that I want to read, well before a lot of the online databases that are available today. And in some respects, we're trying to recreate that. You come in here, you can sort of browse through this, you can get an idea of what's going on in your field, you find something, say, hey, that's interesting, I didn't know that was going on. And we have the leaderboards and we have the dates over here, but let me sort of focus in here. This is generic on computer science. Maybe I want to drill down into my particular subdomain. So I can come in here and I can pick something like artificial intelligence, and now we'll rescope that feed of information in the middle column here to be just the papers and news stories that we've run through this entity linking service that we know to be about artificial intelligence. When I talk about us mapping the concepts, many of these news stories might not even contain the word artificial intelligence or the word AI, but from the context, from reading the stories, from reading the papers, our bots are making that mapping between the concepts and the items. And the leaderboard over here is scoped as well, so now I've got the top 10 authors in artificial intelligence. I can change that. I can say maybe I'm interested in the conferences, and we give you the top 10 conferences. When I talk about ranking and the things that we're doing on paper ranking and the things that we're doing on institutional ranking with the Wisdom Cup Challenge and the KDD Challenge, this is one instance of where some of these rankings come out. It comes out in our search results, it comes out in our leaderboards, it comes out when we drill into some of the topic pages in how we're presenting the rank order of these items. And the calendar events down here as well. So if I'm interested in artificial intelligence, I might want to know that the submission deadline for this particular conference is coming up in the near future. For each of the objects in our graph, for each of the entity types, then, you can also browse into, navigate to a details page about them. So this is a details page for a particular paper. And this illustrates how we have information about the paper itself, when it was published, what conference it was in, who the authors are, what affiliation they have. Here you can see the linked topical fields of study. So this particular paper is about heterogeneous networks and cluster analysis and machine learning and computer science. The abstract. The other process of entity linking as we read the full text of papers that we find on the web is actually reading down into the references section, parsing those references, understanding what papers they're pointing to, and then making those connections in our graph. So from this paper to this paper that it's citing, and if I could scroll down the page here, you'd also see the list of papers that are citing this paper. So you can navigate forward and backward in time from this paper, both the ones that it is citing and the ones that are citing it. And then over here, we have the multiple instances of this paper that we found on the web. So in this case, we found 5 copies, and we need to bring these together in a single unified version. And the interesting thing about this is that this graph grows incrementally over time. We may tomorrow go out and find another copy of this paper. Maybe the first one we weren't able to read all of the references for some reason, and the second one we could. Or maybe the first time we found out about a paper was only because it was through the reference and we didn't actually know where it existed on the web. So not only are we adding more papers to this graph every week, but we're actually adding more details to each paper as we discover more evidence about it. Similarly, you can focus your gaze on a different type of entity in the graph. You can focus your gaze on an author entity, and then you can aggregate together all of the information that we know about that particular author. So in this case, I'm looking at Eric Horvitz. We've gathered information that we have discovered about him that's in Wikipedia. In some cases, we're actually pulling in information from people's public LinkedIn profiles, and then linking that into this author entity record in the graph. Oops, let's go back. Got ahead of myself. So here's another instance of us using this ranking. So we're showing here what we believe to be, by our ranking metric, Eric's top publications. And then we get some aggregations of information here. What are the top journals that he's published in? What are his top conferences? Who are his top co-authors, etc. Same thing can be done at the institutional level. So this is Carnegie Mellon. We aggregate together all of the papers that we know about from Carnegie Mellon or from Carnegie Mellon authors. We have 45,000 of them here in the graph. And again, statistically or from a histogram perspective, who are the top authors from CMU, what are the top conferences that they publish in, what are the top journals. We don't expose this right now on the website, but you can also think about this data temporally. If you did some temporal analysis of the data here, you might discover some interesting analytics about if you're Carnegie Mellon, if you're the dean of the CS department at Carnegie Mellon, it would be interesting to see what trends emerge over time. Which of my authors are publishing more, which ones are publishing less, what venues are we publishing in more or less, how does the topical structure of our papers change over time, what does that tell us about our areas of specialization. So all of that data can be gathered, not right now out of the website, but certainly out of the APIs that we're exposing. A conference, so this is the World Wide Web conference, gives you information about that. You can see other instances, past and future instances of the conference, and again, some of the deadlines around it. And the same thing about a journal. So any one of the entities in the graph gets this sort of focused view here. And then finally, the individual topics. I talked about this topical hierarchy. This is the topic, artificial intelligence, and this is bringing together now all of these papers about artificial intelligence and who the top authors and journals and conferences are there. Everything that I just showed you sort of falls into this category of exploration. Everything that I just showed you is all navigable from the site without ever interacting with the search box at all. But of course, we also do have a search box, and we use some of the techniques that we've developed for and with the Bing search engine exposed on this site to improve on that notion of moving away from strict keyword search, not viewing the search box as you type in a word and we'll match those words to those documents, but actually a more interactive opportunity for us to try and understand the user intent, give them opportunities to help us disambiguate that intent, and really sort of focus in semantically on what they're searching for. So we support a certain form of natural language queries. Here my query is, I want papers by Kwansan Wang in dub, whatever in dub means. And I'll show you what that looks like in the query box model in a second. But you can see here that we have from this query identified there's a person that you're talking about, Kwansan Wang. There's a conference that we're talking about, dub conference, and you get back to the set of papers here, and again these sort of filter views over on the left. You can change the rank order of this. If I just want to see the most recent documents, I can do that. And this little paper right here was the paper that we presented at dub last year in Florence that explains this entire pipeline of how we construct this knowledge graph. So if anybody wants to go in, it's called An Overview of Microsoft Academic Services. And the search box itself, when I talk about recognizing the user intent and providing opportunities for disambiguation, you can see how we're also annotating the query. So if I type the query in dub after 2010 about REC, the icons here are saying, well, dub is actually an ambiguous concept. You could be talking about the conference dub. You could be talking about the concept. World Wide Web is a concept in our topical hierarchy, and it's also the name of a journal. So are you talking about the conference or the topic or the journal? And so we give opportunities for the users to specify. We're also using the ranking here to say it's probably most likely that you're looking for this one based on other aspects of the query or based on the static rank of that concept in the graph. And secondarily, we're using this KESS knowledge exploration service to then provide suggestions for autocomplete here. So if I say in dub after 2010, the recommendations for further refinement of the query are actually going over that graph, and the suggestions are only going to be offered here for the most likely topics that papers in that conference after 2010 had in them. So we're actually using the knowledge in the graph to drive these suggestions. Okay, finally, is this notion of connecting and collaborating and making a much more highly personalized experience. This is an area that we're actively working on right now. So I'm just putting this here as a teaser. Watch this space. Very soon we'll have a lot more to share in this. But specifically moving this from what we have today, which is an entirely non-logged in experience. Everybody gets the same experience. You come in, you search, you browse. What we'll be adding into this is a personalized experience that allows you to create an account, to identify yourself in the graph. And that feed of information is not just about artificial intelligence, but about things that are going to be much more relevant to you. Okay, that's the user experience that we're creating. If I talk now about Microsoft Cognitive Services, there's been a lot of sessions. We had several demos yesterday during the demo showcase about various of the computer vision, the language, speech, other aspects of Microsoft Cognitive Services. But I'm going to drill down in here specifically to a number of areas. Now, Microsoft has been working in the intelligence space for a long time. If any of you remember Bob, Microsoft Bob, even some of the interactions that were built in what Jeff mentioned was Windows Search. In the early days of Windows Search, back when Windows Search was just a grep search engine, we were starting to build in some of these natural language interactions where you could ask questions and it would try to process these in sort of an avatar interaction mode. But over the years, we've made a lot of investments here in a lot of the underlying technologies, and for the most part, these things have been targeted at us shipping these directly to the product teams, who then make the decisions on when and how these get implemented into the Microsoft products. And there's, as I said, a number of areas that we're doing this, but specifically in the knowledge area, the ones that are in that stack that I talked about that we're going to talk about a little bit more today are the Academic Knowledge API and the Entity Linking Service. It's important, I think, to understand that these aren't just simply this isn't just a matter of we in Microsoft Research are building technologies and we are getting them out there. I mean, we are doing that, but these fundamentally come from things that we have been and continue to ship directly to the product teams. So almost all, if not all, of the Microsoft Cognitive Services are actually being used in production at scale across Microsoft products today. And so specifically in the knowledge category, a lot of what we're doing in generating the Academic Knowledge API and a lot of what we're doing with the Knowledge Exploration Service are being used in Bing and in Cortana today. So for example, and this is a little bit of a repeat of what I talked about with the Knowledge Exploration Service yesterday morning, but if you go to Bing today, this is actually a screenshot that I took yesterday of what the Bing experience looks like here in Portugal. So, or in Portugal, it said Portuguese up there, here in Brazil. And I sort of apologize because one of the things when we talk at an international conference about some of these features in Bing, one of the things to realize is that not all of the features in Bing roll out to all of the countries globally at the same time. So I'm going to use this as an example of what search looked like before and after the Knowledge Exploration Service was applied to this. So unfortunately in Brazil right now, you're still in the before state. So if I go into the Bing search engine here in Brazil and I type in latent semantic analysis, you get a very, back up here. First of all, it's not giving me a good suggestion here. It's not auto-completing for me. It's not understanding my intent. It's just seeing that I'm typing latent S, and maybe some people have typed latent semantic before, but it's not understanding the context. It's not understanding my intent. And my search results are very traditional 10 blue links. I've got some web pages that have matched that string, and now it's up to me, the user, to figure out whether or not any one of these is relevant. Once we take that knowledge exploration service, once we build up these knowledge graphs and we inject that into the search box experience, this is the experience of the after. So as I'm typing latent semantic, it's saying, hey, I've got a very high confidence that what you're looking for is latent semantic analysis. I can actually give you a definition of that right here in the search box. I can give you the opportunity to engage with that. Maybe you're looking for something that started with that same string, but if you've clicked on that, then the search results are much more robust. They're much more helpful. They're much more actionable now. First of all, we recognize that you're looking for latent semantic analysis. We recognize what academic papers are and that they have more substance to them than just showing them as 10 blue links. And we can start surfacing things like hot links to the journal, hot links to the author affiliations. You can pivot on the author names. And over here in the entity pane, we show things like the definition, some related conferences, some related people. Even the people also searched for links are not just other strings that other users have searched for, but they're actually the concepts out of the knowledge graph that map to the concepts that people have searched for. So this experience, I think, is, and as we flight these and test these in front of real-world users, much more fulfilling, much more helpful at sort of task completion when people are doing this sort of query. And this also is helpful in disambiguation here. So here, if I type in Susan Dumais, I'm getting the traditional approach here, but where the knowledge exploration service kicks in is when we have enough evidence that what you're looking for is actually publications by a person whose name is Sue Dumais, and we can map that intent onto our graph, then we can make much more robust suggestions here about maybe you would like to refine your query by her co-authors, etc. And that's the pivot that I talked about during the knowledge exploration service yesterday morning about going from simply queries that other people have typed into knowledge-driven queries, query completions. I also mentioned that the information that we're producing, the data that we're producing, is also feeding into our Cortana service. So Cortana started as our digital assistant on the Windows Phone. I'm holding this out there like it's a Windows Phone. It's not. Cortana is now available on Android and on iOS. It's also baked into the Windows 10 operating system. So where the search button is in Windows 10, you have this Cortana interface here. And Cortana has this notion of a notebook, this little notebook icon here. And this is where Cortana stores all of the information that she's gathering about you, of the things that you have indicated to Cortana that you're interested in. What types of food you like, what kinds of music you like, what sort of news you want to get in your news feed, what stock information you want to follow. Cortana gathers all of this information into the notebook. You can go and review it and edit it and change it at any time. But we've added in here this category called academic. So this is available today. And if you go into the academic category, you can control what you want to get notifications on. Do you want to get conference updates? Do you want to know about new papers? Do you just want to know about news? And what Cortana will do is two things. Cortana will suggest to you topics that you may want to have her follow on your behalf. And this is based on your online behaviors. If you've been searching for these things, maybe you're interested in them. Maybe you'd like to have them followed. And then the blue ones up here are the ones that I've confirmed. I've said, yep, I am interested in machine learning and artificial intelligence, so please monitor that on my behalf. And what that looks like then is in my feed of Cortana here, I'm now getting information on new papers, on news items, and on events coming into my feed. So just a nice little thing while I'm waiting for the bus, I can sort of go through and get updates on newly published items. So those are two ways, both in Bing and Cortana, that we're taking the same data and taking the same approaches and shipping them in our products. At the same time, we've been given the mandate within Microsoft Research not just to take the traditional approach of taking our research and handing it off to the product team, having them iterate on it, make decisions about when and how to ship that information, and our sole path to end users being through the product groups. But we're encouraged to take these same things that we're shipping to the product groups and making them directly available to developers, to researchers, in the form of these Microsoft Cognitive Services APIs. And then everybody's happy, at least that's it. So getting back to the stack for a second, let me show you just sort of two quick examples of how we're using the cognitive services in this pipeline. The first one is the entity linking service. So this is actually something that you can interact with on the website right now. If you go to the Microsoft Cognitive Services website, they've got a little interactive text box where you can type in your own, paste in your own text, and it will show you how it does the entity linking of this text. So if I take this block of text and I run it into this service, it will come back and it will identify the entities in this text that it recognizes, and we'll use the context of the paragraph to do the disambiguation. So, for example, we have this word web here. What is that web referring to? Well, from the context of it, it's actually referring to the James Webb Space Telescope. It's not referring to the person James Webb or anything else that's Webb. It takes that full context into consideration when it does that entity linking. And we provide then the JSON results of that. So this API allows you to send in arbitrary text and get back a JSON response object annotated with those entities mapped to entities that are extracted out of Wikipedia, in fact. So we use this approach, not just with Wikipedia articles, but with our own graph as we construct iteratively the academic graph. As I mentioned with the knowledge exploration service, this is also something that you can use with your own data. You can bring your own data, your own schema, your own domain-specific grammar into the knowledge exploration service and build and we'll produce for you an API with which you can build your own applications. But in fact, we've done this with our data, with our schema, and with our academic grammar. We've run that Microsoft Academic Graph through the Knowledge Exploration Service, and we've produced also a REST API, and that REST API is the Academic Knowledge API. So you can see how these things build up with our data through our own services, and you can choose to interact with them at any layer. So mapping let me back up here and talk briefly about this. This Academic Knowledge API has 3 method calls in it. The interpret method call takes natural language queries, unstructured text that the user might type into the search box, and will give you back candidate interpretations for that query. It will say, I think what this person is looking for is papers by the person Kwansan Wang at the conference ... And we'll annotate that query for you, and we'll give you a log prob likelihood or confidence score of each of the interpretations of that particular query. And you can bake that into your application in any way you want. We do this as part of the drop-down in our search box. Having selected one of those, the users say, yep, this is what I'm looking for. The second method here, evaluate, will give you back the set of search results. The set of entities, in the example that I just gave, will give back a set of papers, but your application could be movies or houses or anything else. And then the third one, the calc histogram, will then do aggregation of the relationships between that entity and other entities within the graph. And this is what we use for both the faceting UI and for the aggregations on the profile pages. So mapping those 3 methods onto the website, we use the interpret API to drive that experience. We use the evaluate API to drive the search results after I've selected one of the things in the search box, and we use the calc histogram to drive the filter experience here. And anytime we have a user interaction on the site, if they type another character into the search box, or if they select something from the faceted list on the left, we're re-executing all 3 of those queries simultaneously. If you do this with your own data, or if you use our data in the Academic Knowledge API, we'll generate for you this page, and this is just sort of peeling back one layer of the user experience here, so you can actually see what the individual REST call is. So in this case, I'm passing in the string papers by Eric HOR. I've told it that I want auto completion to be on, so I'm in an experience where I'm actively you think this is stemming is turned on. I'm executing this on each keystroke, and I want to get back, ignore the results there. So this is the ranked list of candidate answers or candidate interpretations for the query papers by Eric HOR. And if you looked at the JSON response object, it would say this is a person, and this is a title, and this is another title. So it's providing that annotation. The first one that's selected here is also being executed down here. So the second method, evaluate, is saying, give me all the attributes back for the structured query, author name equals Eric Horvitz. So we've translated this query, this query here, papers by Eric Hor, to a search for the author, Eric Horvitz. And similarly, the calculate histogram method over here is doing the same thing, but it's giving me back not just a list of entities, but a list of values. Okay, so that's how the whole stack fits together. We would love to have you use the website, but we'd also love to have you use the individual services. There's a number of ways. You can right now, not right now because you can't get Wi-Fi in this room, but you can, when you get back to your rooms, you can interact with any one of these services, the entity linking service, the knowledge exploration service, the academic knowledge API, and the website itself are all available for you guys to use. If you also want to take advantage of Azure resources in your research, if you want to take the Microsoft Academic Graph and instead of downloading the whole thing, you actually want to put it in your own Azure VM and do your own analysis over the graph, or if you want to do other applications that are making calls on the API, there are programs like the DreamSpark program that give you access to Azure resources, and a program that we're running out of the outreach team within Microsoft Research called Azure for Research. And this has been talked about a couple times over the past couple days. But it's a very easy way for you to put in a request for Azure resources to use in your research. So I hope with that information you do two things. You check out our website, give us feedback. We got a lot of great suggestions from people at the demo showcase yesterday about features that they'd like to see. If you have ideas for features, there's a little black feedback button on the site right here. Click that button, vote on features that other people are suggesting, suggest your own features. We use this actively in helping us prioritize the new features that we're going to be adding into this. And secondarily, use the academic API and the other cognitive services in your research. And again, if you have ideas for other things that you'd like to see us expose through these APIs, let us know. Be in touch. Thank you.
Okay, we have time for some questions. Yes.
So I was wondering, so papers is something clear that you have a time and a publication.
I'm sorry, can you speak a little bit closer?
Yes.
Thanks.
So there are some entities that are very clear that they have time associated, like a publication.
Yeah.
But certain connections perhaps should have a time or time period. For example, an author, an entity, an author, for a period of years, it was a professor on a university, and then he moved to another university, then to a company. Is that also already incorporated in the graph structure? So when you look at an institution, can you give a period of time and see the people that were actually attached to that place at that period of time?
It's a good question. So we don't actually, so it can be done. We do two things. So we have information about the author entity in the graph. And so with the author entity, we will typically store with that author entity both a current affiliation or affiliations as well as previous ones. Okay. What we don't model directly right now is you were at this institution for this time range. And it could be done, you would just have to go back through, so we preserve the native information that we crawl out of the document. So we will store, and you'll see this in the Microsoft Academic Graph, you will see for any individual paper, author 1 was at affiliation A at that time period. And affiliation A might be different than what you see on that Eric Horvitz profile page. So that profile page is supposed to be much more about the author's current affiliations. We do have, I can't remember if we're exposing this now, but we do have a place where we can expose past affiliations. We just don't have the sort of time bound. And the interesting thing about that, especially with research publications, is that that's a very fuzzy indicator of when you actually left an institution, because you could still be publishing papers of research that you did at that institution 2 years after you've left it. Yeah, so the data is there. It's just not as nicely represented as I think you're asking for.
Okay, thank you.
There's a question over here.
Why don't you go ahead? You've got the mic.
Thank you very much for your presentation. Within the roadmap of Microsoft, is there let's say, a time frame where all these services like Bing, Search Experience, and Cortana, for example, will be available for Brazil? Because I think this is adopting these tools very early it's fundamental so we don't get used to another tool or another website or another search engine. So what I saw, the experience is very different than what we have now in Brazil.
Have you considered moving to the United States?
Yeah, okay.
No, I wish I could provide that. It's complicated in that Microsoft offering services globally, it's often up to each one of the individual markets to decide what the prioritization is for individual features. And there's local information, there's local language support. A lot of the information that we have in the knowledge graph may only be in English or a subset of that in Portuguese for the Brazilian market. Right now, one of our most furthest along markets in integrating this information into Bing is actually in China. And it's due to a number of factors, but one of the factors is that part of our extended development team works with Bing out of our Beijing office. And so the experience that you get with academic content in Bing within China is more robust than the United States. And as I demonstrated, the United States is more robust than what we demonstrate in Brazil. For me, as being interested in the academic segment, those academic features, the best I can do is knock on the doors of each one of the individual markets, here for the Brazilian market, saying, we'd love to have you guys implement these features here. But it's sort of out of my hands. It's sort of market dependent. I wish I had that roadmap. It's actually something that I'd like to be able to supply. I just don't have it. Yes.
Okay. If I become a kind of regular user of academic, probably I would like to have a change in the information that is provided to me. Is there any plans for tracking the use I do on the academic service? And for example, if I click at such and such a paper, it's not going to present these papers again to me, but will present new papers that I am interested in, I possibly be interested in reading. Do you have plans on this direction?
We have definite plans for a more personalized experience here. So once we get to the stage where you'll be able to log in, then yes, absolutely. Understanding what you've published, and we can infer even what you've read from the papers that you've cited. I hope the papers that you've cited you've read, but we can sort of feed that into this and use that information. But as I said, give us that feedback. The more times that we hear those specific requests and have other people come in and upvote those particular comments, moves it up on our stack rank for implementation.
Thank you.
One over here. There you go.
Hello, this is Iram Calvo from National Polytechnic Institute, Mexico. So I'd like to ask you, you said something about semantic search. So if you have considered, for example, there are some related terms such as supported vector machine and support vector network, which are related. So if I look for one and I want to see also what, in other terms, how it's called, is this considered in the current version of Microsoft Academic?
It has been something that we've talked about, both implicitly and explicitly. So you can actually use the structure of our topic map to do automatic query expansion if you want to. We tend to use it more for query refinement and driving the queries down. But we do have the notion of synonymy in each one of those topics. So you might be typing SVM, and we can map that onto the concept. So this gets back more to the idea of understanding the intent. But in terms of exposing the hierarchy in a way that users could use that to either refine or expand their search is, again, something that we've talked about but don't have any immediate plans to implement that. Again, feature suggestion. Or better yet, the data that I talked about, the Microsoft Academic Graph data, probably the best way to explore that set of related terms is to download the field of study hierarchy file. And so that actually gives you access to all of that hierarchical structure. And we'd love to have people do research or implement prototypes that show how that data could be exposed. So this is part of how we're trying to open up the opportunities here to the broader community, rather than just making feature suggestions of us. Implement these things and share them with us, and let's find a way that we can work on this together.
Okay, that'd be interesting.
All right.
Thank you.
Thanks.
Are there further questions? If not, let's thank Alex again.
Thank you.